Hello. Today is 7.4 special products of polynomials, and it's actually going to be a pretty easy day because there's really nothing skills-based that's new. It's the same multiplying binomials together. The only thing that we really want to talk about is there's certain patterns that come up when you multiply certain types of binomials, and sometimes you can skip ahead and go to little shortcuts. So we're just going to look at a couple of shortcuts, and hopefully we can make it a little bit easier. So the first one is called a sum and difference pattern, and basically what that is saying if you have a number plus another number times that same number just minus the other number, then your specific pattern comes out to just be the first number squared minus the second number squared. Now all of that might seem confusing when you're just talking about any number at all. So let's look at an example and then try and relate it back. What I have here is x plus 3, so a number x plus a different number 3. And then you see in the second binomial I have the exact same numbers, that first number x and that second number 3. The only difference is in the first one I was adding them, in the second one I was subtracting them. Alright, so that's what this meant over here. A and A are the same, so just like x and x are the same over here. And B are the same, 3 and 3. But the difference between the binomials is addition and subtraction. Addition, subtraction. Okay, so that's the setup that we're looking at for this sum and difference pattern. And what it tells me is that my solution should be as simple as just saying, here is the first number squared minus the second number squared. So it should be as simple as the first number x squared minus the second number 3 squared. X squared minus 9. Alright, it doesn't need to be any more difficult than that. Why don't I zoom in a little bit and I'll do A for you. We have x plus 7, x minus 7. Okay, so I'm seeing that I have the same number here as I do here, and I'm having the same number here as I do here. The only difference is that in this case I am adding, in this case I am subtracting. Okay, so I know that this is a sum and difference pattern, and I'm going to go ahead and multiply these two things really quickly just by saying first number squared minus second number squared, x squared minus 49. Right? So much simpler than sitting here and multiplying first, outer, inner, last, and then combining like terms. Try B on your own, and then I'll check it out in class, make sure everybody's got it. Once you have done B and you're ready to scroll down to our next pattern, please feel free to do so. The next pattern is called the square of a binomial pattern. So in the first case we had same numbers but with different signs. One had positive, one had negative. In this one we have same numbers, same signs. Alright, so this first example here, a plus b squared, this is the same thing as a plus b times a plus b. We need to be very careful about that, because a lot of times what students want to do is just take the 2 and say a squared plus b squared. Right? Doesn't the 2 just apply to both terms? No, it does not. It would if we had multiplication in here, but we have addition, so we have a different type of situation. This whole thing right here means it's multiplying itself. A plus b multiplies itself. So I could sit here and I could multiply out a times a times b times a, b times b, and I could get a squared plus ab plus b squared, or I can jump right to the end. I know what it's going to come out to be. So for example, I have x plus 3 squared. Now we need to remember, this doesn't mean that the solution is just going to be x squared plus 3 squared. No, it's going to be x plus 3 times x plus 3. Okay, so there's a lot more multiplication going on than just square the first number, square the second number. But because it's a square of a binomial pattern, I can jump right to the end. I know that it will be the first number, a squared, so that's x squared. I know that it will be 2 of a times b. 2, a we said was x, b is 3, so 2 times a times b, plus the second number squared. So, altogether, that's x squared plus 2 times 3 is 6 times x, and then 3 squared is 9. The second one is the exact same idea, simply with subtraction. I still have a minus b squared, and we are absolutely positively sure to make certain this says a minus b times a minus b, and we aren't just squaring a, squaring b, but instead we jump to this conclusion here. Same thing, a squared, 2ab, b squared. That middle term is the only thing that makes a difference. Alright, so let's go over here. It's going to be a squared, so x squared, and then minus 2ab, so minus 2 times x times 3, right here, and then plus b squared, 3 squared. So in this case, with the same numbers, you see the first case was x plus 3, this one's x minus 3, same numbers come out, but the difference is, in the first case I have positive here, second case I have negative. Let's do one example, and then I'll have you do the second. This says y minus 1 squared. Okay, so that's y minus 1 times y minus 1, and I could multiply that all out, but because it's a square of a binomial pattern, I know that I'm going to get the first term squared minus, because there's a subtraction sign in there, 2y times 1, and then plus 1 squared, which is 1. So when I clean this up a little bit, y squared minus 2y plus 1. And I can skip right to the end right there. Try out part B, and then I'll check it over in class, make sure everybody's got that. And we will move on to our last example. All right, once you have done part B and you're ready to move on, let's take a look at the last example here, example 3. We have two dogs, one that has a black gene, one that has a white gene, and the diagram is going to show the possible gene combinations of an offspring and the resulting colors. So this is what's called a Punnett Square, and if you take a biology type course, you'll see that more, and it's really used for probability, like what is the possibilities that you will have a dog that has completely white fur, or a dog that has completely black fur, or a dog that has gray fur, different probabilities for each thing depending on how it works out. So basically, when you have this kind of square going on, these boxes represent the possible outcomes. So in part A, when it says what % of the possible gene combinations result in black, well, how many possibilities are there? It looks like this whole square comes out with 4 possibilities, and there's only one of them that came out completely black. Like these were gray, this was white, but this one's completely black. So 1 out of the 4 resulted in completely black fur. So what's the percentage of those combinations? Well, it was 1 in 4, which is 25%. Now the second part is where we're going to use a little bit of the knowledge that we just acquired. The genetic makeup of an offspring can be modeled by a specific equation. Use the square of a binomial pattern to model the possible gene combinations of an offspring. So, here's what we want to do. We want to expand this out in order to tell me what the possible percentages for specific types of offspring are going to be. So when I multiply this out, what type of situation do I have here? I have, well, it actually tells me, square of a binomial pattern, which means to me that it's going to be the first number squared, so 0.5b is going to get squared. And then it's going to be plus 2 times this times this. 2 times 0.5b times 0.5w. And then lastly, plus the last number squared. So 0.5w squared. So now I need to clean this whole thing up because this does not look good at all. Right here, all I have to do is square both terms, right? Because I have multiplication on the inside. I apply the exponent to both. So 0.5 squared gets me 0.25. And then the b gets squared. Plus, what's 2 times 1/2 times 1/2? Well, 2 times 1/2 is 1. Times 1/2 again becomes 1/2. So that's 0.5. The b times the w, we can't do that. We don't know it. bw. And then lastly, I have 0.5 squared again. And the w squared. So what was the whole purpose of that? Why did that even matter? Well, this tells me all the information that I was looking for before. There is a 25% chance that it will be just black. There is a 50% chance that it will be a mix, so gray, black, white, gray, and there's a 25% chance that we're looking all white, and that matches up perfectly with the Punnett Square over here. Alright, hopefully this wasn't too confusing and you got it all down. I will see you all next time.